All right. Hello, everyone. This is going to be a bit of a different video where we're not actually creating a specific effect or a certain type of technique is being discussed. It's more about how data works inside of Houdini. I think a lot of students and people that are just starting with Houdini can get confused sometimes with just how data structure kind of goes in and out of Houdini. I myself being one of those people. Admittedly, I don't know everything about every single one of these nodes we're going to discuss, but I'm just going to kind of share what I've learned through my experiences in different studios and exposure to different types of data workflows inside of Houdini. So that being said, just as a disclaimer, I'm sure a lot of the things I'm going to discuss, there may be multiple ways of doing it, and I may even show you the wrong way of doing it. It's just how I've learned how to do it, and it tends to work typically. But again, and if there's something that you see that you're like, oh, that guy is completely off his rocker, please leave a message in the comments or reach out so I can update this video because I'm always learning too. Houdini is a constantly a learning experience, as you all know. All right, so with that disclaimer being said, let's jump into this. The first thing I'm going to cover is FBXs, um, and specifically kind of animated FBXs as far as characters go. In Houdini, we have this FBX Character Import. So if you just type in FBX, you're going to see we have a bunch of these nodes that come up. This character import is the one that I use pretty much most of the time for importing FBX data. Because most of the time, if I'm just doing straight geometry from, say, Maya or ZBrush, I'll use an Alembic. Sometimes FBX, but usually FBX is for animation. So with this node, what we get, so I've just downloaded an FBX from Mixamo. So Mixamo is a free animation website. Hopefully you guys are all familiar with it. It's accessible through the Creative Cloud, through Adobe. It's owned by Adobe. I'll just log in and show you real quick. This is not a Mixamo tutorial, so I'm just going to show you a real cursory high-level overview of how to use it. You log in with your student account, just like you do with Creative Cloud, and then it's going to load up Mixamo. If you already know how to use Mixamo, feel free to skip ahead in this video. I'll put some markers in it so you can skip past certain sections. As Mixamo is loading, oh, here we go. Great. So with Mixamo, you get a bunch of different animations. You can search animations. You get different characters. Feel free to use any of these if you want to follow along with what I'm doing. So usually you'll select character, and then you will let that load. Go to animations, and I'll just say like jump. I'm going to search this animations. And I'm just going to use this mutant jumping here. It's running really slow today. Typically it won't run this slow. And I'm not going to wait for it to load. I don't really want you guys to just sit here and watch paint dry. So you'll hit download. Maybe this will, yeah, we'll just hit download. With skin, all this stuff is just defaults. Frames per second, you can change this to whatever you want. I'm just going to use 30 for now, and I'm not going to hit download because I've got one already. But this is how you can get your own character to do what I'm doing. So what happens is when you hit download, it'll give you an FBX file, and then you'll just point to the FBX file, which I'm doing here. I'm just pointing to one that I already downloaded, the swing dancing. Hit accept. And then what this node looks like typically, if I can, I'll just make a new one. Is I'll grab that swing dancing, and then this is what you'll get when you highlight it. Just a T-pose character. with nothing else going on. So what we want to do with this is extract data, right? So you have these little tick points here at the bottom of the FBX import. And if we roll over these, we can see that the far left is rest geometry, the middle is the capture pose, and then the far right is the animated pose. So let's see what these outputs look like. So if I just got some nulls here, so the first stream we can see is just the T-pose, it's just our geometry. The second stream is the skeleton, and the third stream is the animation, which is the skeleton with deforming applied to it with keyframes. So to get all these things to work together, we can use a bone deform node. And the bone deform will take these three inputs, and then it'll apply the animation to the geometry. Pretty straightforward, but can be confusing, definitely. The confusing part comes when we have these other nodes. As far as I know, these nodes are just older versions of this node or a broken out version of this node. And what I mean by that, this FBX archive import, this was the old way that we used to import FBXs. I don't use it anymore, so we can just get rid of that. And then we have animation import and we have skin import. And basically that just breaks out these nodes into the animation or the skin itself if you wanted to use separate things. You can also use these for retargeting, which I'm not covering in this video. This is something different. We will talk about retargeting when we get into key effects. Just for now, just know that the main thing that you want to use is this FBX import to get characters in. Okay, so that's importing with FBX. So there's other ways to bring things into Houdini besides FBX. There's Alembic, which is a Disney format, which you'll see in their tag .abc. An Alembic file can be a geometry cache file, so you can cache out an animation from Maya as an Alembic. And what you get with that is you don't get bones, you just get a stream of geometry, which is really cool, with one caveat, and this is something that I still haven't been able to figure out yet, because I think it's a limitation of Alembic, is using UDOMs with this. I still haven't been able to figure out a way to use UDOMs with Alembic in geometry caches. So with moving geometry caches, so Alembics will work fine with UDOMs with static geometry, so environments, things like that. But animated geometry, I still haven't been able to figure that out yet. So just a limitation. So that's why I would typically go with FBX if you're using an animated character or something. Then we have a default just BGO, or just a default file node here. This can be pointed to anything. So you can point it to OBJs, you can point it to anything you want. Typically this is not animated. This is just static geometry that you're going to get loaded in. And we can look that there's all different ways we can load this geometry. We can load it as geometry, as a bounding box, a point cloud, a packed disk primitive, which we're going to talk about, packed disk sequence, packed geometry. We're going to talk about packing here in a little bit. But typically file, I use it to bring in geometry, like prop geometry, pieces of foliage, etc. Then another data in, and it's the data. This one's a bit of a different one. It doesn't really deal with data in exclusively, but is the cache node. So a file cache is if you've got a geometry or a particle simulation, something that you're happy with, but you don't want to actually write it to disk in the viewport. You just want to cache it out, and then you've got it cached, so it won't keep caching continually. That's what this file cache node is for. So typically, what you'll use this for is, say you have a particle simulation or a vellum simulation, like a claw simulation. You'll run it into this. It'll be at the end of the node tree. And we'll get into what this is used for as we go through further lessons, but I just want to give you an overview of this. Typically, you'll plug whatever it is into this as the last node. You'll hit save to disk. It'll write to disk. Usually it'll take from a few minutes to several hours to days, depending on how complex your simulation is. Then you have it written out, so then your computer doesn't have to recalculate it ever again. And then you'll just hit load disk, and then it'll load. Very straightforward, but this will trip you up, I guarantee it. In the beginning, especially from my classes, I suggest you do not change these scripts. This stuff constantly messes students up. Just leave it default, and then it'll write to where it's supposed to write based off where you save your file. We'll get more into that in further lessons, but just know for now, just don't edit these. Just don't do it. It'll write the way it should write. Next up, so in file, we have caches, which is basically what I just talked about. This is an older cache node. The file cache is what I just explained. And we also have this stash. So stash basically works like a cache, but it doesn't write it to disk typically. So this is kind of like a temporary cache. So if I was, say I was doing, here, I'll do an example. Say I have like a sphere. And we'll do a mountain sop into it. If I could type. And we'll add animation to this. So we have this add animation to this. So we basically have this moving thing. And if I go to the sphere and I really crank these subdivisions up, let's go even crazy. We'll just do a subdivide. Eventually this will start kind of like chugging, and you'll see it start to cache. And yeah, I really don't want to push it too hard because I don't want to crash my computer. But anyways, we'll just say this as an example. We don't want to calculate this constantly. We like it, and we want to kind of bake it out. So we'll do a cache, a file cache. Go in here. And all this stuff is fine. And hit save disk. And now you'll see it'll write. And it's working really fast because this is pretty simple. And now you'll see it says load from disk. So now you'll see I can disconnect this from the tree. And I still have my animation here. So now this is kind of like a baked asset. I can delete these things, and it's written that thing out to disk, and I've got it here to do whatever I want to with it. I can run more. I can run another mountain on this. Like so. Say change the element size and run some more animation. And keep going and build. Which brings us into packing. So right now this is just reading a straight geometry stream. It's loading as full geometry. It's not packed. You can see under our information here, we've got a lot of points. Well, not a lot, but some points. An attribute, a point attribute. So it's not packed. So we could pack this. So if we go to just pack geometry. Pack primitive disk. Yeah, it's gonna give us all kinds of problems. Let's go over to this other area for pack stuff, just for simplification. All right, so packing. This is a much better illustration of what packing does. So if we look at our information here, we've got points, we've got primitive groups, we've got UVs, we've got materials, all kinds of stuff that this thing is bringing in. So if I copy this, you'll see with each copy, it's multiplying our point count. So now we're up to 1.4 million points with 20 copies because this is not being packed. So there's two ways we can pack this. We can use a pack node, which now this geometry is packed. You see we have 1 point and 1 point attribute, and that's it, nothing else. So if we were to run this into the same copy, you can see now, when we execute that, we have 20 points because we have 20 copies. So we have 1 point per geometry. So this becomes really advantageous when we do this. And now we can go down here, and we have 2,000 points instead of, and I'll have to crank this down because it will crash my computer. If I go over here without this pack, if I bypass this pack, and now it's going to calculate, and we've got 14 million points. So we couldn't, if I go up to 2,000, it'll definitely crash. But if we're packing, you can see I could go up to 200,000, and it added them. So now we've just got still 200,000 points. If I put 200,000 into this without packing it, it would crash. So we don't have to use this pack node though. We have this new option here. It's been around for a while in Houdini. I can do a pack in instance. So now that's going to do the same thing that this pack node did. So I can delete the pack node, and you can see we still have the same result with 200,000 points, which is terrific. It opens up all kinds of opportunities to do cool stuff. Because what we can also do, say we have 3 of these geometries coming in here. So let's go ahead and just move them around. Grab this one. There we go. So these are kind of stacked on top of one another, like so. So if I pack this, or if in my copy I do a pack in instance, we can see we get this. Which again, now we're still at 20,000. And this becomes really, really handy when we do things like this. So we've got tons of geometry, all in real time in the viewport. It's not slowing down. And we've got 972 points. So obviously when this gets into rendering as well, it's a huge, huge time saver. It's something you really need to understand when using Houdini. So the last step on this kind of data flow thing is rendering. And we have lots of rendering. And rendering in Houdini doesn't necessarily mean rendering an image. It can mean rendering a geometry stream. And that's what these guys do, these ROPs. They render geometry streams in different ways. You can do a BGO, you can do FBX geometry, and you can use Alembic to write out. This may be a limitation. You may not be able to write out Alembics in the student version. I think that might be one thing that they have limited, but I could be wrong. But if you find that if you go in here and you go into Alembic and you don't see it here, it will be because it's a student version that doesn't allow Alembic export. But that shouldn't be a problem, at least in the labs. It's just a problem if you're working from home, if you're using a non-effects version or a non-apprentice version, I think. But it's still okay. You can still get your geometry out. And the last thing you can do is you can always, if you just want to do something really quick, like you just want to get a piece of geometry out, like say for some reason I really like this pose and then I want to export this thing out and sculpt on it in ZBrush, right? So I can always right click and go to save and then geometry, and then I can save this to any number of geometry formats. You just can't, the reason why this isn't really the best way to do this is that every time you right click, you kind of have to reset things. You have to re-put the name in. So it's advisable to use a cache as opposed to this. And I think that's just crap. Oh no, here we go. Cancel that. It's advisable to set up caches if you think you're going to do something over and over and over again. But if you just need a quick jump out of your geometry, you can do that with just a right click, save geometry. And that's it. That's just kind of a basic overview of getting things in and out of Houdini. Obviously, we're going to get way more in depth in this. Packing is a really important thing to understand going forward, just to save on computation time and your time from sitting around and waiting. All right, thanks everyone. I'll see you again soon.